Alright, so I went to the store and picked up some parts for working on this electrical circuit. Remember what we're doing now. We're going from my panel, and everybody, if you don't know where your panel is at home, ask and go check it out so you see where it is. But your panel is where your power supply from the road comes into the house, and that's where the panel is there. And it has a whole bunch of breakers on it like this. And if you notice, this one here says 15 when you're looking at it like that. Okay, 15 amps is what this thing is going to trip at. So when it gets too hot and it requires more current, it shuts off. It used to be that we had fuses in here, and fuses for electronics class, you've already seen that, but fuses just was a round device that had a piece of metal that went through it. So the current had to go through that little piece of metal in the inside there. And if the current was too hot or too high, it would actually burn that piece of metal in half, create an opening in the circuit, and that's what that was the problem. And that was how it turned it off. These breaker switches are there to help protect the wiring in your house and the machines that it's running to. Okay? With a fuse, you would have to buy a whole new one to put it back in there, one that has the wire still in it. Breakers, the nice thing is we can just turn them off and on. Okay. So for my panel, I'm going to run a 14 wire out. This is a lighting circuit, and we have a couple different kinds of wires. We have, one is a 12-2 wire, like you see here. 12 is referring to the gauge, the thickness of the wire, and 2 refers to how many conductors there are. There is a third conductor in here, like I said last time, though. It's kind of misleading. It has a white, a black, and a ground inside of this. That's called MC or Metalclad wiring. So you can see how this one is here. So whenever we're working with Metalclad wiring, the one thing we really want to pay attention to as we're wiring this stuff is that our grounds are good. Okay? Why is that? Because the whole thing is encased in metal. And I have to, at some point here, I have to break it. So here's how the one end's going to go. Okay? This end would go into a junction box. So here's a junction box. And you can see on all the edges here, it has these circle punches here. This one has 2. So I could actually have a 3/4 or a 1/2 inch punch there on that one there. 3/4, 1/2 inch. And on the back it has them as well. It also has this little area in the back here that's, you can see I can put my finger into that area there. That's so that this green screw can screw into that, and it can still sit mounted onto a board like this, so the screw doesn't push through and keep it from sitting against the board behind it. So it has a little bump on the inside there that ground screw goes into. Our ground wire, and for the wire that we're looking at here, we have black, white, and green. So our hot, our neutral, and this is our ground wire. This wire here would get wired to this box, and that would prevent this box from ever becoming electrified. So instead of when you touch this, it zapping you, it has a good ground to go out to what I showed you before out there in the lawn, where I have a big copper rod that goes down to the ground by about 5 feet, and maybe not 5 feet, maybe 3 feet, but it goes down in quite a ways. It's not just a 1 foot copper rod in there. It goes down far and gets a good ground connection. When I said I had never done anything like this before in the first video, what I meant was I've never worked with MC wire, which is Metalclad wire. So I don't even really know how to get to this stage. So you can buy a tool, and I think in the second video I said I was going to buy it just for educational purposes. Well, I go to Weavers. You know, I try to keep it. Weavers did a really nice job during this coronavirus, where they have you wash your hands as you enter Weavers and blah, blah. They're closed Sunday because they are disinfecting the whole place on Sundays, blah, 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 blah. Anyhow, they're doing such a nice job keeping their store safe that's the people that I wanted to be helping out, the ones I want to shop from. So in going to them, they didn't have the device that cuts this outside shield off. Okay. If you recall, I have in our classroom, we have those yellow pliers that we cut the Romex off with, and we can pull that right off then. With this one here, I'm going to go down about 8 inches. When I go into a junction box, I give myself a little bit more than I normally would. And I'm just going to bend this. So now you can see my wires through there. And now I'm going to take a pair of side snips or dikes. They're called either way, is a fine way of saying it. And I'm just going to cut that metal. Is this the best way? No. But can you imagine what the concern is going to be for me after doing this? After cutting this metal. When you cut metal, a lot of times you create a burr on the edge, or you create a really sharp area. And why would I be concerned about that sharp area? Because that sharp area can cut through the insulation on my wires down below there. And if it does, I can electrify here's this off here, and this is just a winding, you know. If you look also the way that it's done, it's got a smooth side and a rough side. So when you're pulling this, feeding this around an area here, there's really one direction that it wants to feed easily, and it won't go back the other way very, very easily. So I cut that part off. I actually want to make that a little bit longer. So I'll unravel this a little bit more here. And I've never tried unraveling it like this. We're going to see for the first time here. You can already tell that you probably want to wear gloves when you're using this stuff, because I can feel like if I grab this wrong, I'm going to cut myself. Okay, now I'm going to cut that. Okay. I gave myself more on the other side. I think that I would like to have more, but I'm going to stop it there. I'm just going to snip this all the way back to right there. Okay. Now, we have that sharp edge there. That sharp edge needs to be protected. So they have these, they're called bushings, okay? And I've used these bushings in other areas too. Wherever I have metal to metal where I'm concerned about a wire that's being bent over an edge that could be sharp, these things go in. So I'm going to slide this thing in here. I'm going to cut a little bit more off this side here. Just get a sharp corner there. Try to get rid of that sharp corner, even there. And then I'm going to slide this around my wires, and it's going to get shoved into that metal. Now I'll cut off this plastic here. Again, this is the first time I've used this stuff, but there's a lot that makes sense to me about it. So I have that shoved in, and that's just holding it there so that that metal that I cut there is not going to cut into the insulation here. And very honestly, I guess people that work with this all the time, they use that cutter and it does a better job of cutting the ends than I would. But I'm actually going to, I'll just take some electrical tape and put that around there to make sure that that piece of plastic stays there. Now, we talked about before how these have to go into these boxes, how we have 1/2 inch and 3/4 inch knockouts here. Well, I'm going to knock out one of these 3/4 and show you how to do that. So if you look at that side there, there's a circular piece, there's one little spot right here where it seems like it's not cut out all the way. So that's what's going to knock it back through, back and forth. And I'm going to use a pair of linemen for this. So I popped that through, and now on the inside here, I'm just going to grab that and twist it back and forth. So now we have a hole here. Remember, this is what's sitting up in my joists above the shop in there, and this is where I'm going to be going into. This is also where, if you look in the shop that I have here, up at the top, I have wires going into that, and then I have these cords that are all hanging down. And I have those throughout the shop because I don't know where I'm going to be putting machines in here, so I want to make sure I have plenty of places to do it. But if we notice on these that I've done, and I'll show you this one here, the one that's up there, What's coming out the bottom there kind of looks like, let's see if I can get all the way up to it, show you. Kind of looks like a Chinese finger cuff. Okay? That Chinese finger cuff is to prevent any kind of strain for when I'm pulling on this extension cord here. Because instead of grabbing at one spot, where like, if you remember like the video I did with the lamp, we made that knot, so if you pulled on the cord, you'd be pulling on the knot, and that's where the strain would be, rather than actually where you screwed it to the two sides of the lamp there, the wires. Well, with that, we have that Chinese handcuff there, and in our shop at school, we have that too. On all the cords that come down over top of the work tables, we have that same setup there. And what it does, it puts all the strain on the insulation around the conductors and not on the conductors themselves, which is much, much safer. Okay? So every time we're going into someplace, like here's a box here, and it has this fitting on the top here with a screw into it. This is for conduit, for metal conduit. And I'll show you one of that too. So here is metal conduit. I've painted it white, but it goes down into this box, and you can see that it goes into a fitting just like this, where the metal goes into it, and then I use the screw to tighten against it. What I want to show you in this video here is I want to show you how we attach different types of conduit into boxes that we have here, because we have all kinds of different clamps for doing that. But we want to make sure that it's in there and it's not going to, if people pull on it, there's no risk of anything coming loose. So here's our MC wire with the conductors out. By the way, these are not stranded wires. They are solid wires. I turn them and they stay in the posture. Okay? So now, there's two different connections that can go onto this. If this box is sitting up there and here's our opening, and our wire is coming over from this side, then we can use a 90-degree angle fitting that would go onto that. If my hole's on this side here and it's coming in from this side, then I have a different fitting that would go on there and it would sit straight. So let me show you both. Let me show you how both of those work. We have a screwed piece here that has the little square ends on that, and really I just tighten that as much as I can by hand, and then I go ahead and I tighten it a little bit with a flathead screwdriver. So in this case here, that piece would go through. On the back side, it gets threaded. It's tough to do this while I'm trying to show you. Once it gets started threading, it's not a problem. Let me start it. Okay, so that's started in there now, it's locked in there. And if I just go ahead with a screwdriver, or sometimes a pliers can get in there and do it as well. But if I just turn that with a screwdriver, I can get this tightened up against it so that that fitting stays in there snug. Okay? And at that point, I can go ahead and run my wires in through and bend them so they fit in there. Bring that wire all the way through there, and then turn the set screw, which is over on this side here. Turn that set screw tight. And now that's hooked up. Okay, that set screw is holding us tight onto there and our wires into there. Okay? So that is the straight kind going in. So of this Metalclad stuff, one is going to be going into the box here, where it's going to be picking up the power. And the other one is going to be going into where the lamp is. So this is going to sit outside, underneath, in the wood like that. And this is one of those old construction boxes where I'm just going to set it up through the wood that I've cut a hole into, and then I'm going to tighten it. And you can see when I tighten it, the tabs turn out. So the tabs turn in, I turn out. And as I'm tightening it, those tabs will come down and they'll force this thing to sit nice and flush up in there in the hole. Okay? So one's for the light and one's the box. Okay? The 90-degree angle, it's the exact same thing as what we did here. Goes in 90, and it gets threaded in the exact same manner the last one did. Okay. Wires go in and down through, and you want to have that as loose as you can to be able to feed those through. Remember, as you're feeding this, you don't want to just pull hard because you could be scratching off the insulation as you're going. So kind of feed and pull, feed and pull. That goes through. That gets all the way in there tight, and then we go ahead and tighten that in here with these clamps. So that's how our MC is going to get attached to this box. Okay? In next video, I'm going to show you how our roll mix gets attached to the box, and I'll show you the switches that we're going to use that as well.